Hello. Today I'm going to repeat the lesson on basic PCA denoising of spectrum images with the program temDM MSA. It was already posted some time ago, but the program was changed a lot since that time. Spectrum imaging objects are now different, and also video recording software is much better. Well, let's take some spectrum image, for instance this, and you can look at spectra with Gatten tool, this one. We can scroll over the spectrum image and see the spectrum. temDM MSA also allows you to pick spectrum. Just choose spectrum picker. It would be another green colored marker, but basically it acts the same way. Well, what is the problem? When we average several pixels in such picker, our spectrum is quite nice. But if we look at only one pixel, it is quite noisy. So we are going to denoise that, and for that purpose we will use the program temDM MSA, its basic version. Well, how we proceed? Just in temDM menu, choose MSA PCA, which is principal component analysis, and then tool proceed. Now the tool appears. Well, in this tool we have a few buttons, and the normal treatment flow is from top to bottom. Well, you are not obliged to remember the function of each button. There is a certain information mode. Just click this icon I, and now pressing any button would output short information about it. For instance, what is container? It's just to prepare container where you will keep all your multivariate statistical analysis results. It's quite convenient. Some program creates for that individual folder, but it's too extensive. It's better to create one file, container. Well, everything what you did will be stored in this container. You will see how it works. Okay, the next button is PCA, just to extract as many principal components from the data, as many as you want. Good. And finally, to reconstruct. It means to reconstruct data with number of principal components you want. Good. Now let's exit the information mode, and now clicking each button would really induce some action. First, we have to prepare a container. Well, first, system asks you whether you are going to use the full energy range, or you might reduce that, like reduce twice. But in this case, we will use the complete range, increase twice. So complete range, just confirm. Well, and this is our container. It's actually not data cube, but just two-dimensional image, but it consists all spectrum image information in the hidden form, in the form of text. So we will further work with this container and do not touch the original spectrum image. Okay, so as you remember, we move from top to bottom, and the next block is extraction of PCA components. And of course, it's logic to press button PCA. Good. What happens? Oh, thank you for using temDM MSA. I thank you also. Just press OK. Two components are now extracted. it's the minimal number of components, default number of components, but it is just for overview. So what you have? You have here the average spectrum and also the spectrum of two components. First component, second component. Well, you can close this without saving. The good thing is that all this data are already saved in the container. So just close everything without saving. Don't care much about storing the MSA data. This is quite interesting plot. It's just a plot of data distribution among between two main principal components, first and second. And probably you will find further that this plot is very informative. But now we will just close it without saving. Good. It was only two principal components, but two is typically not sufficient. It's just for overview. Specifically in this data cube, there are much more components one needs to explore further. So let's just set 20 components, extract 20 components, and press again PCA. Well, the good thing with temDM MSA program, you do not need to overwrite every time your PCA work. You can just choose, and this is default option, add new components, and components which you extracted previously will be just extended. We are going to do exactly this. Add new components, confirm. Well, now system extracts up to 20 components. Takes some time. In the advanced version, it would be 3 or 5 times faster. But for this data cube, even this is not as long. Okay, thank you, of course. And then close without saving this information. Maybe stop for the moment and not close the script load. Variance of components versus component index. It shows how significant are given components. We start from the first component, and this has very large significance. And we go to components with higher index, and they are less important. Well, it actually shows not the variance, but logarithm of variance. So it might be negative for some. It might be confusing, but we can show that in another form. Draw line. Okay, that is a more common script load, just variance of components versus the component index. Okay, now what we have to do, we have to reconstruct our data using only few major components. And how many components to choose, it's a very important, very big topic. I'm not going to touch it in this tutorial. There are several advanced methods for that. For this data cube, I just choose 6 components. Why 6? It's another topic. Just you choose 6. Well, script plot we can safely close without saving. And now the next box to use is reconstruct data cube. We have to input how many components we need, and as I said, we will choose 6 components in this case. Okay, Then having in front our container, just press reconstruct. Well, confirm that all these 6 components you do need and press OK. Reconstruction is quite straightforward, and now we have the reconstructed data cube. Well, I suppose it is improved, but let's check. For that purpose, we have special tool to compare 2 spectrum images. Just click original spectrum image and reconstructed spectrum image, and then choose so-called twin spectrum picker. And then you have 2 spectra overlaid. We can move the marker over the spectrum image. 2 spectra will change synchronously. I mean, the full spectrum is original data, and the red line is the reconstructed data. First of all, you see that the reconstruction generally follows quite closely to the original data. But if we zoom a little bit, we see that the reconstructed data are much improved, denoised. And that is quite good, and that is what we wanted. Okay, how to stop this twin spectrum picker? Just to close the spectrum window without saving, with keeping Alt pressed. Press here. Okay, good. So maybe now we compare how good was our work. Finally, logically, one needs some elemental maps from spectrum images, and let's open the spectrum maps which I extracted from the original, not denoised spectrum image. Here we are. It's titanium map, vanadium, lanthanum, and strontium. And then let's compare that with maps obtained from denoised spectrum image. So you see that maps are indeed much nicer. Titanium, vanadium, lanthanum. Well, strontium is not improved very significantly, but that's because strontium is really very noisy peak at quite high energy. Okay, so what we can do else with this tool PCA Proceed? We can also make some kind of compression of our data set. Let's choose this MSA container. MSA container, as I told, it consists all original data, and if we store it, it would be as large as the original data cube, even a little bit larger, because it consists also some service information. But what we are going to do, we are going to compress that, and this is compressed data. It's much more compact if we try to store it. Just compressed data, and now compare the size. This is original SI9, and this is SI9 compressed, and you may see that it's much more compact, maybe 30 times shorter. And why? Just because it does not keep all original data cube. It only stores the useful PCA components, which are quite little, in this case 6, but we can anytime to extract the complete denoised spectrum image from this compressed cube. Just press extract. well, it would take some time because in fact it's a reconstruction of data cube with these 6 components. The only difference between action of extract button and reconstruct is that system doesn't ask you how many components are needed for reconstruction because it uses the number last time applied for reconstruction. Okay, so probably you can compare the spectrum image of original data with this reconstructed data cube, reconstructed from compressed container. Again, we choose twin spectrum picker, and we see that data are denoised significantly. Okay, so that was a repetition of basic PCA processing. I hope now you are well updated. That was a basic version. Advanced version allows you to do everything a bit better, much faster, and so on and so on. But in general, you can also stay with the basic version. Well, that's all for today. Thank you.